What is up, guys, and welcome to Hack the Coding interview hosted by Region 3. Today's company of emphasis is going to be Google. Just a heads up, if there's a weird tapping sound going on in the background right now, ignore that because we're just going through a PowerPoint. It's not going to sound like this during the actual coding session, but yeah, just wanted to put that out there. So here's our team. There's myself. I am your regional telecommunications chair. And Onaja in the middle there, he is our publications chair. And to the far right is Ben, who happens to be our public relations chair. Missing from the photo is Kennedy, our secretary, and Elliot, our academic excellence chair, who without him, this wouldn't have been put on in the first place. So thank him. So who am I? My name's Esther Onema, and I'm a junior at the University of Central Florida. I'm pursuing my BS in computer science, and once again, I'm your Region 3 telecommunications chair. Listed there are some of my past, current, and upcoming internships, as well as the position that I served in each of them. What this series is not. Okay, so this is not a guaranteed set of questions that will be asked during your interviews. These are questions that have appeared in past interviews, which is why I chose them. This isn't a one and done tutorial either. I want you guys to challenge yourself by going beyond these problems in order to become better prepared. Supplemental problems will be provided at the end of each video, so don't worry about finding the right problem because I will give you a few, but I also encourage you to go beyond that and find some more on your own. Of course, this series is not sponsored. These tutorials are being provided to you guys 100% free of charge as long as you ace your interviews. What this series is for: coding in real time, approaches to essential interview questions, reviewing basic programming concept for novice and experienced programmers. So some of the subjects covered will be algorithm analysis, data structures, problem solving, and etc. If you're watching this tutorial, I'm hoping that you have at least taken an intro to programming class, and if or if not, hopefully also an intro to data structures class. This is also serving as virtual paired programming. I do not want you guys to just watch this video and say, yeah, I'll code it later. I want you guys to watch this video, code it with me so that you're able to identify any things that you're unfamiliar with or things that you think you want to get better at. And last thing is, we're here, or the region is here to help you relieve your first time interviewing jitters if this is your first time ever interviewing with any company. So, materials needed for today's video. You can use the IDE of your choice. Personally, I like to code in a text editor because it helps me to understand my code more. But if not, if you don't want to do that, you could use an IDE such as CodeBlocks, NetBeans, IntelliJ, your choice. But just know that typically in-person coding interviews are often conducted on whiteboards, or I've been in interviews where I was asked to code on a sheet of paper in pen. So yeah, it could get as far as that. So then you want to code in the programming language of your choice. Don't get scared or discouraged when you see me in today's video coding in Java. I have made sure to only provide solutions that can be easily replicated in the programming language of your choice, and also know that the languages used in each video will vary. Like, I know for certain the Microsoft series video is going to be in C programming because that's a company that likes to ask you questions that are to be done in C. So another thing that you're going to need is either a smart TV, a phone, or projector screen to watch this video on. Once again, the purpose of this video is for you guys to code along with me. And of course, have an optimistic mindset. Drink some water, No caffeine, you don't want a jittery, like impatient mind. Put yourself in a productive environment, either if that's by yourself or other programming friends, and don't forget to take breaks. If you find yourself getting stuck or discouraged, drink that water, pause the video, and come back to it when you're ready to tackle the problem or code again. One more thing, in an interview, always talk out loud. This allows recruiters to see how you think, and I've personally been in interviews where I was talking out loud and my recruiter caught on that I had misinterpreted or misheard something he said, so he was able to catch that. And in the long run, that was great because if I just like stood at the board, not saying anything, and coded out my entire solution, he would have, one, said it was wrong, two, it would have been a waste of time, and three, I probably wouldn't have gotten the job. So always be sure to talk out loud, explain your thought process to your recruiter or interviewer to let them know you know what you're talking about and to give them a better idea as to what kind of approach you're taking. Another thing, if you can't understand the question being asked, request a test case. Typically, I like to ask, what are my input parameters? Am I taking in two strings? Am I taking in a character array? Am I taking in a list? What are my return values? Am I returning a Boolean? Am I returning an integer? And what are the restrictions regarding the code itself? Like, for example, your interviewer could tell you, I want an O of one space complexity, meaning you cannot create an additional array, additional hash set, or anything of that sort to solve your function. So these are important questions to ask. And if you cannot think of the optimal solution, brute force it first. One answer is better than no answer. Trust me, I have like done interviews where, one candidate coded a solution. It wasn't elegant, but that put him at a much higher bar than the candidate that said, I don't know, and coded nothing. So when taking the brute force approach, let your interviewer know you are brute forcing it, and if time allows, then you can go back, look over your brute force solution, and begin to optimize it. Also, never cave into uncertainty. But if your recruiter is giving you hints, you probably should take them. But then again, when I say never cave into uncertainty, I have heard of interviewers asking their candidates, are you sure you want to take this approach? And it isn't necessarily to steer them wrong, but it is to get the interviewee to show that I am very certain in what I'm coding and I know what I'm talking about. So just ensure that you make yourself look confident with your solution, but also don't be cocky about it. And once again, remember to take hints if given. Last thing, make a great impression. Leave all of your nerves at the door. You've already made it this far to an interview. The last thing that you have to do is just ace the interview. One thing I like to do is ask 1 to 3 questions about the company at the end of my interview to make sure like I leave the interview itself on a good note with the recruiter. And it also shows that I am passionate about working there and that I've done my research, which leads me to my last point. Do your research on the company. Let's get started. Once again, supplemental problems will be provided at the end. So let's get started with the first problem in today's video. So this problem is called FizzBuzz. It's one of the most classic and essential problems that you could ever be given in a coding interview. And today we're going to be looking at it in a pretty unique way. So what is FizzBuzz? We're going to be writing a program that outputs numbers from 1 to n. The first condition is, for multiples of 3, it should output fizz instead of the number, and for multiples of 5, output buzz. Another condition is, for numbers that are multiples of both 3 and 5, we're going to output fizz buzz. So here's an example. Given that we provide the value of n to be 6, the number 1 should just print 1. When the number is 2, we print 2. 3, we print fizz because 3 is a multiple of 3. 4, print 4. 5, print buzz because 5 is a multiple of 5. And 6, we're going to print fizz because 6 is a multiple of 3. And it's just going to go as long as n. Yeah. So aside from that, typically in an interview, your interviewer isn't going to ask you to code the main function, essentially because they would assume that you know how to create a main function, and also it takes away from time in an interview. So they're probably going to provide you with the function outline. If not, I usually just ask my interviewer, okay, what are my input parameters, which would be n in this case, an integer, and what am I returning from the function? And in this case, it's nothing. We're printing to the screen. So yeah, let's get started with this code. So I like to comment my code simply because it's a much cleaner and elegant way to express your ideas to your recruiter to your recruiter or your interviewer without them having to ask questions in the middle of you coding. Some may disagree with this approach simply because it takes away from time, but for me, I get a better idea, a better blueprint of what I'm doing when I comment my code first before coding. So the first thing that we're going to do is initialize fizz and buzz variables. And then from there, we're going to go iterate in a for loop that goes from I to n, right? So within that for loop, we're going to increment fizz and buzz variables. I spelled increment wrong, but let's just keep going. So the first case is if fizz is equal to 3 and buzz is equivalent to 5, we're going to print fizz buzz, right? And then we're going to reset the values. Ooh. Ooh, I cannot type today. Reset the values of fizz and buzz, right? So else if fizz is equivalent to 3, we're going to print fizz and then reset the fizz variable. And then, of course, you're going to want to do the same for when the number is just 5. So when buzz is 5, just change that to buzz. We're going to print buzz and reset the buzz variable. Otherwise, like we said here, if it's not a multiple of 3 or it's not a multiple of 5, then we're just going to print the number. So else print the number I, where I is, of course, the iterated value we're traversing in our for loop. So let's actually get to coding. And coding is going to be a lot easier because we've already outlined the blueprint to our code. So it's just left up to us to fill in the blanks. But before actually coding this, actually, let's discuss that in the end. But let's go ahead and say for int I is equal to 1, I is less than or equal to n, and I plus plus, whoops, I was not reading. We need to initialize our fizz and buzz variables. So int fizz is equivalent to 0, int buzz is equivalent to 0. And then we can go ahead and create our for loop. where do I want to add my comments? Not my comments, my braces for the for loop. We'll go around here. So the first thing that we're going to want to do is increment the fizz variables and the buzz variables. So if fizz is equivalent to 3 and buzz is equivalent to 5, print fizz buzz. Otherwise, reset the value. Well, not otherwise, but afterwards, we're just going to reset the values of fizz and buzz. So then we say if fizz equals 3 and buzz equals 5, system.out.println fizz buzz. And then we have to reset the values of both fizz and buzz to 0. So fizz is going to be equivalent to 0, and buzz is going to be equivalent to 0, right? Yes. So then else if fizz is equivalent to 3, right? We're going to print fizz, so system.out.println fizz. And then we absolutely cannot forget to reset fizz. So fizz is going to be equivalent to 0 again. And then repeat the same thing for buzz. Else if buzz is equivalent to 5. Yep. And reset buzz. Otherwise, we're going to print the number itself, which of course would be I. So else, let me make sure these are lined up. Yep. Else system.out.println I. And there is nothing to be reset after that. So let me make sure I got everything right. All right, so let's just save our code and run it. Whoops. Okay, and let's run our code now. Enter a value for n, let's say 15. All right, so given the value 15, this looks about right. 1, print 1, 2, print 2, 3, print fizz, 4, print 4, 5, print buzz, 6, print fizz, and then everything else here looks right up to 15, which is a multiple of both 3 and 5. We print fizz buzz. Awesome. So we have working code. Let's talk about a very important topic that your recruiter is going to ask you after coding out your code and explaining to them what does what. Your recruiter is more than likely going to ask you, what is the runtime of this function? Now, I'm not an expert in runtime, but I could explain the gist of it. But aside from that, I highly, highly recommend that you do some research on this topic, because depending on the complexity of the problem, the runtime may begin to get a little bit more difficult to explain. But in terms of this problem, it's pretty straightforward. So essentially, I like to look at the runtime as, okay, given the input that I'm providing into my function, how is my function going to react? How is it going to behave? So we never know what exactly the number that's going to be fed into the function is going to be. So that should kind of give you a hint as to what exactly the runtime is going to be. So let's say for the function, my user enters 3 as n. So the function fizzbuzz will evaluate the numbers 1, 2, 3. Did I say 3? Yeah, 3. So it's going to go through this loop 3 times. But let's say our user enters 100 for the value of num in terms of our function. So our function is going to run in the for loop for as long as 1 all the way to 100. So what exactly does this mean? This means that our function, the runtime itself, relies simply upon the value of n. So I would express the runtime of, well, I would express the runtime as O of n, where n is equivalent to the number provided by the user. So runtime is O of n, where n represents the input number provided by the user. And then sometimes, I haven't been asked this in an interview yet, but if you want to add a little flair to your, I guess, interview knowledge and demonstrate to your recruiter that you know what you're talking about, you can also discuss the space complexity. And again, this is a topic that I highly, highly recommend you guys look into. I'm no expert on it, but I can once again explain the gist of it. What is the space complexity given a function, right? Did I have to add any additional data structures or forms of memory in order to get my function to run, such as an array or a hash map or anything that would, I guess, take up space? And in this case, I didn't. I just created 2 variables, fizz and buzz. So our space complexity would just be described as O of 1, where if you have studied runtime and space complexity, you know that 1 just represents a constant number. So regardless of the input that is provided into our function, the space complexity is always going to be O of 1 because we didn't create any additional data structures or arrays or anything of that sort in order to like get our function to work. Not sure if that makes sense, but I can create a separate video on runtime and space complexity if that's something you guys want to know more about. But aside from that, you have your runtime, you have your space complexity, and the last thing is common approaches to this problem. Now, many of you might have been thinking, oh, I can just use the modulo operator, saying, okay, if number mod 3 is equal to 0, print fizz. Number mod 3 is, well, number mod 5 is equivalent to 0, print buzz, and so on. Let's not do that simply because not just in the Java programming language, but yeah, in the Java programming language, using the modulo operator is quite expensive to our program itself. It could kind of make it actually run slower. And like I said, it's not just in a Java programming language level, it's also in terms of looking at it in the CPU architecture level, meaning that the div and the remainder functions are often costly to our program, meaning it would run slower. So the purpose of these tutorials, I don't want you guys to just provide working solutions to your recruiters. I'd really like you guys to provide intelligent solutions for your recruiters so that you can demonstrate, hey, I know what I'm talking about. And not only I know what I'm talking about, I know the reason behind the decisions that I make in my code. So yeah, that's FizzBuzz. Guys. So today we're going to do one of my personal favorite problems. It's called the intersection of two arrays problem. And the problem statement essentially is, given two arrays, write a function to compute their intersection, where the first condition is each element in the result must be unique, which is a resulting array, and the result can be in any order. So let's just run through this example. We have the first array consisting of the values 1, 2, 2, and 1, and the second array consisting of the values 2 and 2. That means the resulting array, which will return the intersection between the two arrays, will be just 2. Now, some of you may be wondering, why didn't we put two twos? Because at least two twos appear in both arrays. Well, let's remember this condition right here. Each element in the result must be unique. Therefore, we already saw 2 in both arrays. It's only going to be listed in our resulting array once. And another example would be, okay, given these two arrays, we have 495 in the first array and 94984 in the second array. The intersection between these two arrays are going to be 9 and 4 because the values 9 and 4 appear in both arrays. So awesome, awesome, awesome. So once again, I have already outline my main function. Typically, once again, your recruiter is not going to have you code the main function. They want you to just code the meat of the code, which is the actual function itself. So in my main function, for those that are curious, I just created two arrays. I'm printing to the screen the contents of these two provided arrays, and then I'm going to call the function that we will be coding in this current tutorial, and that's going to return an integer array, and that integer array is just going to contain the intersection between the two provided arrays, and yeah, it just prints it to the screen in this line right here. So once again, typically the first thing I always ask my interviewer is, okay, what are my input parameters and what would I be returning in this function? Yeah, so that's going away. And then my interviewer would tell me, okay, you are going to be given two integer arrays, which we have here, array 1 and array 2, and you're going to be returning an integer array, which we see here. This code can easily be replicated in Java, so don't, in C or any other language, my bad. So don't worry that I'm coding this in Java once again. So like any good programmer should, we're just going to start by outlining our function by just typing out the code first. So the first thing that we're going to do is declare a hash set. Oh, and one more thing before we even start coding this problem. I know a lot of you may be thinking this problem is super easy. All we're going to have to do is just create a hash set, store all of the values from one array into that hash set, and then run a for loop, analyzing each value from the second array and see whether or not if its values appear in the hash set that we created and just return it. No, 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 no. That is not what we're doing, and we will explain why at the very end. So let's begin. So the first thing that we're going to want to do is declare a hash set to hold all of our found intersections. Note again, we are not creating a hash set that will contain all of the values found in one array. We are simply creating a hash set that will store the intersections between the two arrays, the common values found between array 1 and array 2. So then the second thing is we're going to want to sort both arrays to simplify, looking for intersections, aka similar values. And then from there, we're going to create two pointer variables representing the index of each respective array. And the arrays we're referring to are the arrays that are being passed into our function. And then we're going to run a while loop. And the conditions are as long as the pointer variables are less than the lengths of their respective arrays. Basically, we're running a while loop rather than a for loop because we're never exactly certain how we're never exactly certain if both of the arrays that we're being given are going to be of the same length. And I'm going to delve into a little bit more as to the reasoning, more reasoning as to why we're using a while loop versus a for loop or any other loop. So let's just continue with this outline and I'll explain it when we're actually coding. So then in the while loop, our first case, if, oh, and one more thing, our pointer variables, we're going to call them I and j. So if array 1 at I is less than array 2 at j, what we're going to want to do is increment I. And then the next case is if array at I is actually greater, array 1 at I is actually greater than array 2 at j, we're going to increment j. And then the last case would be they're equal. Both array 1 at I and array 2 at j are equal, so case else, whoops, add either array 1 at I to hash set or array 2 at j to hash set. And the hash set is our intersection hash set that we are defining here. And then from there, let me make sure we have everything correct. Oh, and of course, the last thing that we're going to want to do is increment the value, the increment pointer values I and j. Yep, good stuff. So then, once we are out of the while loop, right, we want to create an integer array that has the same size as our intersection hash set. And then we're just going to also create a index variable for our integer array. This is going to be known as our result array. So just to make this clear to you guys, result array. Okay. And then we're going to loop through, oops, my phone. So we're going to loop through our intersection set and add its values to our result array. And don't forget to increment the result array index, which is index variable here. And then at the very end, recall that we're going to be returning an integer array, so we're going to return result array. Okay, awesome, good stuff. So now we are ready to begin coding. So first and foremost, we said that we are going to declare a hash set of type integer. Whoops. And then call it intersections. Perfect. Equals new hash set. So we're using a hash set because this is a data structure that when you insert into it, it has a runtime of O of 1. And in the best case scenario, when you're pulling from a hash set, retrieving a value from the hash set, the runtime is also O of 1, which is the fastest, most best time that you're ever going to want with like just any kind of sorting algorithm, function. O of 1 is just fast. Although there may be, okay, so that's a topic for another video that we're not going to get into today, but just know that O of 1, awesome runtime. So the next thing that we want to do is sort both arrays to simplify looking for intersections. So we're just going to say arrays dot sort. Whoops. Whoop. And then we're going to sort array 1. And arrays dot sort is it's provided by the Java library as well as the C library. It's known as qsort, and Python library as well, I believe. And essentially what this function does is just sort your array from smallest to largest, and that should be array 2, which is awesome because 90% of the time a recruiter is not going to have you create your own sorting function. So next thing, we want to create 2 pointer variables representing index of each respective array. Yep, good stuff. And now we're going to run a while loop. So while I is less than array1 dot length and j is less than array2 dot length. Okay, and so why are we using a while loop rather than a for loop? Let's look at it this way. Let's say array 1 consists of 1,000,000 elements and array 2 only consists of 3 elements, right? So the size of array 1 is 1,000,000 and the size of array 2 is 3. When I'm calling this function, I don't know the sizes of both arrays in advance, and I don't know how many elements they're going to have in common, which is why we use the while loop. The while loop is just a great way to traverse arrays when you're never exactly sure when you're going to need to stop traversing them. So in our case, we're going to stop traversing the array when either of these 2 pointers are equivalent to the length of their respective array. So once we're in the while loop, we're going to say case if array 1 at I is less than array 2 at j, right? We're just going to increment I. So basically what's happening here is we're saying, okay, in our array, let's sort these first. So we're given these 2 arrays and they're being fed into our function. And after calling sort, array 1 is going to look like this. 1, 2, 3, and array 2 is going to already be sorted because it only consists of 1 element, which is nice. So essentially what I'm saying is if array 1 at I, which both are I and j are equivalent to 0 at the moment, if array 1 at I, which is equivalent to 1, is less than array 2 at j, then we're just going to move this pointer forward, because from that we understand that there's no value in array 2 that is equivalent to 1. So it would make sense that our array, since it's already sorted, it would make sense to move forward to the next pointer and compare that value with the rest of array 2. If that doesn't make sense, I strongly encourage you to try testing this algorithm against other examples, smaller examples, bigger examples. It would just make more sense, I guess, when you do a little bit of more work with it. But for the purpose of this tutorial, I'm going to do my best to explain the best solution that I would provide in an interview. So, yep, we did that. So else if array 1 at I is greater than array 2 at j, right? We're going to increment j instead. And that's essentially just what we did here, but using the j pointer variable. But for the purpose of the example I did provide you guys with, it's only of length 1, so there would be nowhere else for our j to go, if you follow my drift. And the last case is else. If this is the case, so array 1 at I is neither greater than or less than array 2 at j, it means they're equivalent, right? So in that case, we're just going to say intersections dot add array 1 at I. We could have even put array 2 at j, because in this case, both of the values at their respective indices are equivalent. And then we're just going to increment I and increment j. Good stuff, good stuff. And yeah, recall once again, our hash set is going to contain all of the values that are both found in array 1 and array 2. So once we're out of the while loop, we're going to be creating our integer array, which will serve as our result array. So let's get that started. So we're going to say int result is equivalent to new int of size intersections dot size. So this is just the size of our intersections hash set. Yep, so we're creating a result array that is the size of our intersections hash set, because basically all we're doing is throwing all of the values from our intersections hash set into an integer array, because our function asks us to return an integer array. So then int, let's just call it result index is equivalent to 0. And then we want to now loop through our intersection set and add its values to our result array, and we're going to increment the result array index, where in this case it's actually called result index, not index variable. You guys get the point, but yeah. So we're going to use a for each loop, another really awesome, elegant way to traverse arrays in the Java programming language. So integer num, and then intersections. So basically what this for each loop is doing is we're traversing through all of the integers in our intersection hash set, and num is just going to represent the value at whatever current index we're evaluating in the intersections hash set. It will make more sense, I guess, when I type in this next line of code. So we're setting the result array at result index equal to num, where num represents a value that is present in our intersections hash set. And then of course we're going to increment result index, and at the end of all this, return our result array. So return result. Okay, I'm really going to be crossing my fingers and hoping that this code runs on the first try. If not, that is okay. Good programmers make mistakes. So the first thing that I want to do is compile my code. Oh, okay, array. It should be arrays.sort. Okay, I think that was the only big issue. Let's try that again. Awesome, awesome. And now let's just run my code. Whoops, I compiled it. Yes, awesome, awesome. So our code is working. So remember we fed in to our function these two arrays, 1, 3, 2, and 2. And the intersections of our two arrays were found to just be the value of 2, and that's it. Awesome, our code works. Now let's talk about two very important topics that your interviewer should ask you at the end of your interview. And if they don't ask you, I highly, highly recommend you just throw this information in there simply because it makes you look like a better programmer, a more well rounded programmer, and a programmer that knows what they're talking about. So, first thing is runtime. What is a runtime? In the case of this function, the runtime will be, in the worst case scenario, the function that would take the most, like whatever function or line of code that would take the most amount of work. So in this case, we have two arrays, right? And we don't know their size going into this when the function is called. But let's say both arrays are, well, one array is the size of 1,000,000 and the other array is like the size of 20, okay? So in this case, traversing the array in the while loop isn't going to be the most amount of work. It would actually be sorting it if, let's say, the array of size 1,000,000, every single element is out of place, which means our sorting algorithm is going to be having to do a lot of work. So in Java, when you call arrays.sort, the sorting function that's being used is called quicksort. And for those of you that have studied different sorts and sorting algorithms, that kind of stuff, you know that quicksort has a runtime of O of n log n. Um, and I know that C uses quicksort as well, but I'm not sure of the sort that Python uses. I'm assuming it's quicksort, but I I suggest you guys Google that. But yeah, the runtime for this would be whatever part in your code that's going to require the most amount of work. In this case, it wouldn't be traversing the array, it would be sorting the array. Because again, let's say we have one of the arrays or both of the arrays have 1,000,000 elements in each of them, and every single one of those million elements are out of place. That means your sorting function is going to be doing the most amount of work, meaning your runtime would be O of n log n. Next thing is the space complexity. Sometimes this is asked, other times it isn't, but either way, we're still going to review it. The space complexity in the best case would be O of 1, okay? Which means essentially no additional space was added when we are calling this function. An example of the best case scenario is, let's say we have both of the arrays are either the same size or one array is larger than the other. It doesn't matter. But the intersection between them only contains one value. And let's say that one common value between the two arrays was like the number 2. Then our hash set would only contain one value, which is less than n, representing the length of either of these two arrays. So with that one value, our space complexity is essentially nothing. It's just O of 1. And that's the best case. But the worst case for our space complexity would be O of n. So let's say one array contained 20 elements and the other array contained 10 elements. And the array that contained 10 elements were all found in array 1. So our hash set would be of size 10, which equates to n, which is the length of the smaller of the two arrays. Or both of our arrays could be the same size, right? And every single value found in one array is found in the second array. So once again, O of n would be our worst case space complexity because n represents the length of either the smaller of the two arrays, or if they're the same size, it would just be the length of the array. But best case space complexity, essentially nothing is stored in there, or maybe we have like one or two values stored in there, essentially less than the length of either of the two arrays, or worst case scenario, O of n representing the length of the smaller of the two arrays would be our worst case. Last thing is Another common approach some people may have to approaching this problem is they may say, okay, rather than using a hash set to store all of the intersections, let me just use a hash set to store all of the values in array 1, and then I'll just create a for loop, traverse over array 2, and see if any of the values in array 2 occur in the hash that I created based off of all the values in array 1. Um, for those of you that aren't following along with what I'm saying, don't worry about it because that approach isn't really better. Simply because let's think of it this way. Let's say array 1 had 10,000 elements and array 2 only had one element. That means because we're putting all of the values of array 1, 10,000 elements, into our hash set of our integer, we're using a lot of wasted space because array 2 only has one value, and that value isn't guaranteed to be found in array 1. So it's just a lot of unnecessary space being wasted. Um, Again, if you don't grasp the concept of runtime or space complexity, there are, I would say, hundreds of articles, YouTube videos on the subject. Um, and yeah, if you guys have any questions or need any more points of clarification regarding this problem, please feel free to reach out to me. But you've already made it this far in the video, so kudos. Hey guys, and we are doing our last problem of today's video called valid palindrome. So the question is, given an array, determine if it is a palindrome. Note, a palindrome is a word spelled the same way forwards and backwards. So let's say we're given the character array of the word Bob. B-O-B is spelled the same way forwards and backwards, so we return true. Although given the word crow, we're going to return false because clearly crow spelled backwards is work. So once again, I have my two test arrays that we're going to be testing our created function against. And I'm going to be passing in two of these arrays when testing it itself and printing whether or not it was found to be a palindrome with the result variable, of course. The function outline is we're given a character array called word, and we are going to return a Boolean, which is true or false, or in the C programming language, I guess you would return 0 or 1. And I've already outlined the function because we're running a little short on time, so let's get started. We want to create two iter pointers, so we're going to say one of them is 0, int I is equivalent to 0, and int j is going to be equivalent to, let's take the length of our array minus 1. Basically, I is going to start at the beginning of the given array, and j is going to start at the end of the given array. So we're just going to run a while loop on the condition that one pointer doesn't run over the other, meaning while I is less than j. And we just have one condition to check actually. So if word at I does not equal word at j, return false. Otherwise, we're just going to increment I and decrement j and continue. And then at the end of all this, if we've gone through and compared the beginning and the end, the beginning and the end, and we still haven't returned false, that means we do have a valid palindrome, so we will be returning true. So once again, what's going on here is, let's say we're looking at the word Bob, right? That means I is going to start at 0 here, and j is going to start at the end of our array. Now, because word I is equivalent to word j, we're not going to fire false. We're going to increment I, and we're going to decrement j. At this point, I and J will be equivalent, meaning they'll both be located at the index where O is, meaning our while loop will exit because the condition only runs as long as I is less than J, not if they're equivalent, so we return true. Once again, I highly recommend you guys test this with other test cases, but for the time being, let's just see if this code works. Oops. True. And the word that we had given it was Bob. Awesome, correct. That is a palindrome. So let's pass in the second array instead. And that is a palindrome as well. And let's just trip it up a bit and just not make it a palindrome and see if it still works. And false. Correct. So there you have it. Last thing is the runtime is O of n, where n represents the length of the character array, and space complexity is O of 1, because we didn't create any additional arrays or hash sets or any sort of data structure to hold any additional information. And there you have it. Supplemental problems. All right, supplemental problem number 1. Given two strings s and t, write a function to determine if t is an anagram of s. Note, an anagram is a word, phrase, or name formed by rearranging the letters of another. So in the first example, it spells out the word anagram, and then the second word is just a rearrangement of the word anagram, which is why the output is true. The second example is the word rat, and the string it's being compared to is the word car. Clearly, car is not a rearrangement of the word rat, so we're going to return false. And at the bottom there is a function outline. Your function is anagram is going to take in two strings or two character arrays if you're looking at the C programming language, and return a Boolean, true or false, or 0 or 1 in the C programming language. Problem number 2. You're given strings J representing the types of stones that are jewels, and S representing the stones you have. Each character in S is a type of stone you have. You want to know how many of the stones you have are also jewels. The letters in S are guaranteed to be distinct, and all characters in J and S will be letters, so don't worry about any extra characters like ampersand or any of that thing. And letters are case sensitive, so lowercase a is considered a different type of stone from uppercase A. Note S and J will consist of letters and have a length of 50 at most, and the characters in J are distinct. So as you see in input 1, J is classified as either being a lowercase a or an uppercase a, and in the string S, we have one lowercase a and two uppercase a's, so 1 plus 2 gives us the output of 3. And then example 2, J is just having the character lowercase z, and the string that we are analyzing has two uppercase z's. Well, neither of them are lowercase z's, so we return 0. As you can see in the function outline, we are given two strings, or in the C programming language, it would be two character arrays, and then we're returning a number, integer. Last question. We're doing the exact same thing as the palindrome question we just did, but with numbers instead. This one has a little trick to it, so it may not be what you think it is, but either way, give a go at it. And hopefully by next week, all of the solutions to not only just covered in today's video, but also to the supplemental problems, they should be posted next week to the Region 3 GitHub. Thank you for watching, guys. I will see you next week.